Hi everyone, and I hope you're enjoying the session so far at Build 2024. I'm Chiara, and I'm super excited to talk to you today about React Native for Windows and how you as a developer can use the platform to ship great desktop experiences. Before we jump into content, a little more about me. As I said before, I'm Chiara Mooney, and I'm a current software engineer at Microsoft on the React Native for Windows team. I've worked with this team for about 3 years, and I specialize in releases, testing, and accessibility. For some of you here, you may already be familiar with React Native and React Native for Windows. For others, this may be the first time you're hearing about this platform, so let's go ahead and do a quick reintroduction. React Native is an app development platform which allows developers to code in JavaScript and build cross-platform mobile applications. In contrast, React Native for Windows is a part of a larger effort at Microsoft known as React Native for Desktop. The goal of this effort is to add desktop as a target to React Native, allowing developers to use their same JavaScript source to build iOS, Android, Windows, and macOS apps. We've been working on this project for about 5 years and have customers internally within Microsoft, such as Office, who serve over 7 billion views of React Native powered UI to users every month, or parts of the Windows OS, such as Start Menu's Recommended section or the Accounts page in Settings. We also have external partners, such as Meta and the 𝗦𝗽𝗲𝗍𝗂 app, who recently migrated their mobile app to desktop using React Native for Windows. And later on in this presentation, we'll hear a testimonial from the 𝗦𝗽𝗲𝗍𝗂's team about their experience using the platform. Now, if you're watching the session today, you might be listening in for a few reasons. Maybe you have an existing React Native for mobile app and are interested in adding Windows support to your app. Maybe you're interested in learning more about Microsoft's cross-platform options. Or maybe you have a React web app and are investigating options to build a native application for desktop. Today, we'll have lots of great applicable information for all groups. In this talk, I'll be walking you through building a React Native for Windows web app, which will have some UI, some native Windows functionality, and will reuse some code sourced from a React web app. And by the end of this talk, the hope is that you'll walk away with number 1, a better understanding of when React Native for desktop would be the right platform solution for you, and number 2, a few practical tips for how you can build a great product with React Native for Windows. So let's go ahead and dive right into content. For today's talk, I'm going to say that hypothetically, I'm a developer on a team that uses React to build a web app for note-taking. We have great adoption on web, but feedback we hear from customers who are using our competitor solutions say they prefer to use an app directly on their desktop rather than open another web browser. So from an adoption standpoint, our team sees developing a desktop app as a big market opportunity to reach a new set of customers. Given how saturated our market is, it's also critical for us to generate loyalty amongst current customers by providing a unique end-to-end experience. Right now on web, we face some design constraints, so we're excited that creating a native app will give us more control over customizing the look and feel of our product. When we were thinking about which app platform to select, a couple of factors crossed our mind. First, our team isn't big enough to support building a true native client app on every platform we want to target. So we're looking for a solution that lets us share our code. We'll be seeking a platform that offers cross-platform support. So a solution like 𝗦𝗽𝗲𝗍𝗂𝗍 wouldn't have worked for us. Additionally, we're really interested in having native look and performance over a web view experience. So a solution like Electron or PWA wasn't the right fit either. Finally, we're mostly a web dev shop. So rather than training and hiring a new set of native devs, we wanted to be able to reuse our React skills. With React Native, we would be able to reuse our JavaScript expertise. With all of this in mind, React Native for Windows is the right fit for my team's new desktop app. If you're interested in hearing more about which client platform is the best fit for your app, I'll have resources linked at the end of the presentation to documentation, as well as the other client platform talks taking place at Build this year. All right, so with that, let's go ahead and dive into our first demo, which will show how my team first instantiated a React Native for Windows app?
All right, so I'm a developer at a company with a note-taking web app that is now looking to build a React Native desktop application. Let's take a look at how I would get started. The first thing I'm going to do is to initialize my app. I'll do this by running React Native CLI command. Once my app is created, I can then build my application, once again through the CLI. Once my application is running, I can now begin to make edits. With React Native, any edits that I make to my JavaScript source will live reload into my application after I save my changes. For example, I can edit the text of the Step 1 title to include an exclamation point, or I can change the color of the highlight text to red, and these edits will appear after I save. Okay. I'm now ready to start coding my application. Let's look at a React code snippet from my company's note-taking website. We can see this page has UI to support adding a note title and notes. Let's translate this code from React to React Native. First, I'll migrate the styles for the page. We can see most of these styles translate automatically. Some style props like padding exist in both React and React Native, but expect different input types. I'll delete the padding style for now, but if I wanted to keep it, I would just swap my string value for a numeric one. Other props like border will have to be swapped for their equivalent React Native prop. We'll use border width set to 0 to achieve a similar functionality. Some props like box sizing we can simply remove because they won't be needed for our React Native implementation. Next, we can translate our component code. In React Native, we will use the text input control instead of input and text area. This control automatically supports text editing and placeholder text. Once we make our changes and hit save, we will see all of our changes load. Note, you could also use Copilot or the chat pane in Visual Studio Code to do the work of translating React code to React Native for you. With just a few swaps, we now have a React Native app that's visually similar to our original React web page.
All right, let's reflect on a few key takeaways from that demo. First, we saw that it was easy to instantiate, build, and run a React Native for Windows application. Next, we saw that I was able to quickly code UI in JavaScript that rendered controls with near native look and feel. Next, we saw that I didn't need to use any knowledge of native development to get started. All of my code changes were made in JavaScript. Next, we saw that the developer experience with React Native was super smooth. Any file changes I made in JavaScript automatically appeared in my running app through React Native's Fast Refresh feature. And finally, we took a code snippet of React web code and saw how coding in React Native is fairly similar to coding in React. The non-UI JavaScript code was reusable, and the UI code was translated fairly easily. Now that we have a running app with some UI, I'll want to add some functionality to my application. For this, our team needs to access the power of Windows APIs. Let's take a look at what my options are to access Windows APIs from React Native for Windows. There are 3 options that developers have here. The first is that they can use a cross-platform native module. Many native modules exist within the React Native community and offer functionality such as navigation, device info, and web views. For more information on native module availability, go ahead and visit reactnative.directory. The second option is that developers can call Windows APIs directly from the JavaScript using a package called React Native 𝗦𝗲𝗀𝗃. React Native 𝗦𝗲𝗃 is a library that lets you call the full suite of native 𝗦𝗲𝗃 APIs without needing to write custom wrappers. And the final option is that developers can drop into the native code within their app project and call the APIs directly. For our app, we want text-to-speech functionality so users can play back the notes they have written. Let's take a look at how to add text-to-speech functionality through Windows APIs in our React Native for Windows application.
Now that I have some basic UI written for my note-taking app, I now want to add the feature of playing back the notes a user has written. I'm going to do this through a text-to-speech API. The first way I could implement this is using the cross-platform native module React Native Text-to-Speech. To add a native module to my app, I'll run yarn add React Native Text-to-Speech. Next, I'll run the autolinking command npx React Native autolink windows. This will link the native module to my app's native code. Next, I can rebuild my app, and I'm ready to use the React Native Text-to-Speech module within my code. I'm going to add a button control to my app page that users can press when they want their notes read aloud. The button control takes a title and an onPress function. This is where I'll add my call to the text-to-speech native module. First, I'll need to import the text-to-speech module. Next, I'll need a variable to track the contents of my notes. Then, I'll need to add the onChangeText handler to my text input control, so my notes variable remains up to date. Finally, I'll set the onPress prop of my button control to a function which calls the text-to-speech API on my notes variable.
This is my note.
The contents of my notes are announced when the Read Notes Aloud button is pressed. The second way I could implement this is to use the React Native 𝗦𝗲𝗀𝗃 package. To add this package to my app, I'll once again run yarn add React Native 𝗦𝗲𝗀𝗃, and then I'll run the autolinking command, npx React Native autolink windows. I will need to make one change outside of the JavaScript for this option. I'll need to edit my app's experimentalfeatures.props file to include which Windows namespaces I'll be using APIs from. Then I can rebuild my code. I'll reuse the same button and notes variable I wrote before. Next, I'll substitute the React Native text-to-speech import for the import of React Native 𝗦𝗲𝗀𝗃. Then I'll write a function which will take in a string and announce its contents. Notice my implementation uses Windows.media APIs as if I'm in the native code, but I'm still in my app's JavaScript source. I'll then swap out my button's onPress implementation for my new speak function, and when I hit save, I can see my notes are once again announced after pressing the Read Notes Aloud button.
This is my note.
It is important to note that React Native 𝗦𝗲𝗃 is a Windows-only module, so if your app requires cross-platform support, you will need to wrap your usage of React Native 𝗦𝗲𝗃 in a platform check for Windows. We won't have time in this presentation to walk through the case of adding text-to-speech functionality by dropping into my app's native code directly, but there is information linked on how to do this in the session resources.
Okay, so what are the key takeaways from this last demo? There are lots of options for how to access Windows functionality, and our goal as the React Native team is to have done the work so our developers can stay in the JavaScript. We want to lower the barrier of entry to developers who want to engage with Windows APIs but might not have Windows native development expertise. We made it easy to access the native APIs when you need, but you can stay mostly in the JavaScript layer. Now that I have a standalone app with some UI and some logic via Windows APIs, from here my team would continue to add features to our app until our product is complete. But later down the line, there may be some potential scenario where I would want to embed some of the React Native content that we have written in a different pre-existing project. For example, what if our note-taking product could be added as a feature to an existing application like the Adobe Suite? Well, there's a way to do this in React Native. It's called brownfield development, and it's a strategy teams like Office and parts of the Windows operating system are using today to ship React Native experiences and features inside their existing products. In contrast to the fresh standalone app that we built in part 1, brownfield development is the strategy of adding a React Native view to an existing application. Brownfield development with React Native is possible because React Native apps are native apps. As a result, developers can embed a React Native view inside the visual tree of a larger existing Windows application. Let's take a look at this in action in our final demo.
Office also uses React Native to build Accessibility Assistant, which helps make your documents more inclusive. Office went with React Native for this experience because it's a great UI framework for Office on Windows, it makes code sharing easier, and Office already had a similar React Native feature, so it was easy to adjust the source for a new use case. Another React Native experience in Office I want to showcase is Microsoft Excel's Show Changes panel, which allows users to see which changes were recently made to the Excel workbook. Notice that both the Show Changes panel and Accessibility Assistant have visuals consistent with Office UI styling, creating a seamless look throughout the application. React Native is featured in many other Office experiences, including commenting and persona cards. Let's look at another example of React Native embedded within an existing application. Let's look at a few apps within the Windows OS. Here is the Start menu's recommended section. This view of the Start menu is powered by React Native. Notice once again, we have seamless visuals. The Settings Accounts page is also built with React Native. From all of these examples, we see how teams at Microsoft are able to light up selected experiences with React Native while preserving the remainder of their application's source. We won't have time in this demo to walk through the full list of steps to host a React Native view in an existing application, but let's take a moment to look at the native code of a React Native for Windows app to get a better understanding of how brownfield development with React Native would work. If I open the Visual Studio solution for my note-taking app, I will find a main.page.xaml file that was created by the React Native template. If you are familiar with WinUI development, a page with this syntax is very familiar. These files are where the UI for a WinUI application is specified. If we look at the contents of this file, we see it has a page element and one child element called React Root View. This element is how all of our JavaScript UI is loaded into our app's visual tree. It functions similar to any other XAML control and continues to render its contents correctly when surrounded by other XAML controls. For example, if I were to wrap this element in a WinUI stack panel and then add a WinUI text box above the React Root View element, I would reload my code to see that my app now has an additional WinUI text box rendered above my original UI. My app now contains one WinUI text box rendered directly in XAML and one WinUI text box rendered via React Native. If there was an existing Windows app where I wanted to add a React Native view with my note-taking page, the source on the native side would look similar to this. The existing Windows app would have a bunch of XAML source, and then I would add one or more React Root View elements into the XAML files where I wanted to expose a React Native view.
From this demo, we can see that Microsoft trusts the React Native platform with key experiences in Office and Windows. React Native powered UI fits seamlessly into the existing Windows experiences. And going forward, you as a developer can scale your usage of React Native to fit your product's needs. At the beginning of my presentation, I mentioned we'd hear a testimonial from the 𝗦𝗲𝗀𝗻𝗀 app team. This was an app who recently supercharged their React Native app for Windows. Let's hear from Will, the lead developer on the 𝗦𝗲𝗀𝗻𝗀's desktop app, about his experience using React Native for Windows for the first time.
Hi, I'm Will Schaller and I lead development on the web and desktop platforms at 𝗦𝗲𝗀𝗻𝗀s. 𝗦𝗲𝗀𝗀s is a service that connects people who are blind or have low vision with volunteers, companies, and an AI model for visual interpretation tasks. We chose React Native Windows to build our desktop application so that we could leverage our React experience and parts of the codebase of our existing React web app, but still have access to native UI components like navigation controllers, so that we could ensure a really smooth, seamless, and fully accessible experience on desktop. We don't have a lot of Windows development experience in-house, but we were up and running with React Native Windows super quickly, and we had a working prototype in less than a month.
So we've talked about what's currently possible with React Native, but what future support is on the horizon? Currently, there is an effort called Cross-Platform React. This has been in development at Meta for some time, and the goal is to be able to reuse React UI code directly on native platforms leveraging React Native without having to rewrite the code to be React Native specific. This is already being validated in production, and its key piece is called React Strict DOM. Here at Microsoft, we've been working together with Meta on this vision and have created a complementary library to cover non-UI web APIs to make even more code directly usable across web and native platforms. Together, these two efforts are working towards a future where code is written once for web and deployed natively across many platforms. You might have seen last week at ReactConf, Meta has done a big push for XPlat React. If you're interested in more information on this topic, definitely check out their talks at that conference, and then links for all of this work will be posted in the session resources as well. All right, so today we walked through creating a sample React Native for Windows app, which reused some code sourced from a React web page and used native Windows APIs. As I close out this talk, I want to stress a few key takeaways from today. First, we saw that you can leverage your existing React knowledge to build React Native applications. Second, we saw that Microsoft is betting some of our biggest businesses on React Native, including Office, parts of Windows 11, and more. Third, we saw that you can harness the power of Windows APIs in React Native. And fourth, we saw that you can customize and scale your React Native usage to meet your product's needs. If you'd like to learn more about the React Native effort and start building React Native for Windows apps, please look at the resources on this slide. Our team has also given several talks at past conferences speaking more about Microsoft's usage of React Native, how React Native's performance compares to that of Electron, and more. Check out the links on this page to view those talks as well. And finally, if you'd like to learn more about Microsoft's investments in client development, check out our other sessions taking place at Build this year. And with that, thank you so much for listening in on the session today, and I hope you have a great remainder of your experience at Build.